Okay, Trig students, this is section 5.3. Since we have had snow days and I wasn't sure what was going to be happening, I decided for the sake of our dual credit class that I needed to record the next lecture. This is not one I wanted to leave you guys on your own about. So please, before you get into the homework problems, I've got some at the end of this, please shut your Chromebooks and just pay attention to this. If you want to get in Google Classroom and follow through with the PowerPoint, it is posted there. So this is going to make a lot more sense when you kind of understand where we're going. So we are talking today about the graphs of sine and cosine. I'm not talking about where they land on the unit circle. I'm talking about graphing out all the values on like an XY axis of the sine function and then the cosine function. And then transformations of those graphs. The transformations of those graphs are very similar to the ones that we've learned on all the other graphs, whether you shift up or down, whether you stretch it vertically, whether you stretch it horizontally, whether you shift left or right, all the same kind of deal. It just looks a little weird on the sine and cosine. And then the last section, using graphing devices, they talk about graphing calculator. I'm going to be skipping that because we have Desmos. Thank the good Lord. So we're going to be talking about graphs here. So this part is a little confusing. I don't want you guys to get confused with this. All they're saying is that the sine and the cosine function are both cyclical. And as we know on a unit circle, okay, as you go around the unit circle, you repeat values. This is 2 pi around, right? This is pi over 2, pi, 3 pi over 2, 2 pi. So 2 pi makes a complete circle around. So what they're saying is that all the values of sine and cosine repeat every 2 pi. So this little n here, the n just means it could repeat for 2 pi, it could repeat for 4 pi, it could repeat for 6 pi, it could repeat for 8 pi, any multiple of 2 pi. That's what the n is for, so don't let that confuse you. So again, just the periodic properties of sine and cosine. One complete period of a sine function takes 2 pi to get through one complete period, to get through one full graph. All the possible values in every quadrant takes 2 pi. Same thing for cosine, okay? So this may be a helpful chart to you. Again, I missed, before we got canceled for snow, I missed handing out the unit circle graph. But again, it is included in your Google Classroom. It's been posted, so you might want to look at that. I think I posted it back with 5.2. So anyway, you might want to check that out. It's a little easier to read, I think, than the table here. But this just goes through all the possibilities of pi, okay, across the top, what t could be. Remember, t is your terminal point, and where it lands on the unit circle, then the value of sine and cosine, depending on where that is. Okay, so this picture is the graph of sine. Now, the one here on the left gives you the individual values. Okay, it looks a little strange, but this red one with the little dots on it, it is literally mapping all of the values. Now, keep in mind, this is a little different than our XY graphs. Because sine and cosine are trig functions, unless, you know, we're talking about a decimal approximation for radians, we're not just going to put in 1 or 2. We're going to put in, you know, pi over 6 or pi over 3 or pi over 2. And so all of these values, pi over 6, if you pop up, that's the value. Pi over 3, if you pop up, that's the value. Now again, if we go back, what is the sine of pi over 6? It's 1/2. Okay, so back on this graph then, this value right here would be 1/2. So the sine of pi over 6, so our terminal points, if you will, are the t, notice is your x-axis, okay? and your y is the value of the function. Notice the value of the function oscillates between +1 and -1. Sine or cosine, unless they've been transformed, unless they've been shifted or manipulated, they never give you a value above 1 or below -1. Okay? Now again, if they get transformed some way that we're going to talk about later, then they can. But these shift between 1 and -1. So if you graph all of these, again, sine of pi/2 is +1. Sine of 5 pi over 6 is also 1/2. Sine of 2 pi over 3, if you look back on the chart, 2 pi over 3 is the same as pi over 3, which is √3/2. Now, let me kind of tell you here that pi, if you're thinking unit circle, again, this is kind of like quadrant 1. This is quadrant 2. This is quadrant 3, like on the unit circle. This would be quadrant 4 on the unit circle. Okay, so if you remember, sine is like your y-axis on the unit circle. So the first and second quadrants are positive. It's above 0. Okay, the third and fourth quadrants are negative. It's below 0, if you think about your unit circle in relation to the actual graph of sine. Okay, so, and you know that at pi/2, let me go back here, pi/2, if you can see me draw that dot, the value of sine is 1. That's where it's straight up on the unit circle, right? At 3 pi/2, the value of pi is, or sorry, the value of sine at 3 pi/2 is -1. It's straight down on the unit circle, like it would be on the y-axis kind of thing. So this is kind of showing you what the graph of the individual sine and cosine functions are. Now, notice on the graph to the right here, they've got this first one outlined. I don't know if you can see me drawing over top of it, outlined in red. That's our typical sine curve. This is one period. To get all the values of sine that it could possibly have, positive and negative, it takes 2 pi to get through one period of sine. Then it just repeats, okay? Notice at 2 pi, it just repeats over. And we know that because we've talked about reference numbers, and you know, if we have a value that we're trying to put in that's greater than 2 pi, we subtract 2 pi off of it and then look and see what that value is on our unit circle. So all this is showing us is that it keeps repeating, okay? Same thing with cosine. Now, cosine starts in a different spot. If you think about it, sine again was our y-axis. Let me go back a minute. Sine was our y-axis, so the value, think about again the unit circle, the value of sine right here is 0, because this is our sine, right? Value is 0. And then it's 1/2, and then it's, you know, √3/2, and then it's 1. This was at pi/2. So we are taking those values and graphing those values individually. So sine starts at 0. Okay, now, in contrast here, cosine, again, think about your unit circle. Cosine, if you remember, is your x-axis. So cosine starts at 1. So if you put in a 0 for your terminal point, the value of cosine is 1. Okay, pi/6, it's going to be 3 pi, or √3/2. Pi/3 is going to be, this would be 1/2. Pi/2, again, this point right here, this one mirrors this one on the unit circle. So pi/2 would be 0, because again, cosine, if you look at this point, this is the point 0, 1. This is the cosine value. This is the sine value on your unit circle. So cosine is 0 at pi/2. So the cosine function, instead of starting at 0, it starts at 1. Now it still has the same kind of shape. It's still making these little waves, okay? But we go all the way down and all the way back up. Okay, again, one period of the cosine function is between 0 and 2 pi. Again, they show you this here on the graph at the right. Okay, cosine, one period goes from 0 to 2 pi to get all the possible values cosine could be. Then it just repeats. Again, it's like a wave, okay? Just keeps repeating. says the graph of the sine function is symmetric with respect to the origin. This is as expected since sine is an odd function. You all remember we talked about odd functions. Odd functions, if I put in sine of negative t, that gives me negative sine t. Okay, symmetric with respect to the origin. That means you'd essentially flip-flop the signs on your x and flip-flop the signs on your y. Sorry, if it's an odd function, I think I just said even, but sine is an odd function, okay? Now, cosine, however, is an even function. An even function looks like cosine of, oh, I hate my dead spots on my board. Let's try it over here. Cosine of negative t equals cosine t. Okay, if you remember on an even function, regardless of whether you put in a pi over 3 or a negative pi over 3, you're going to get the same answer. Those are symmetric with respect to the x-axis. Cosine function is symmetric with respect to the x-axis. You can see that on the previous graph. Look here. Look at this piece, that window right here that I just drew a block around. It is symmetric with respect to the y-axis. Okay, that's what they're talking about. Even functions, even and odds. Okay, now, graphs of transformations. I want to first remind us, while I have a blank page here, different transformations. Let's talk about your basic parabola. If I had y equals 2x minus 1 squared plus 1. Let's just talk about all the different transformations going on here. This is a vertical stretch. Okay, we know that. This is a horizontal shift, and this is a shift right. Okay, we would go right 1 in this case. All right, this right here, this plus 1 is a vertical shift up 1. It's the same thing with these. Now, the difference with these, with our sine and cosine functions, is any vertical shifts they typically write in the front. So they would write this as 1 plus 2 blah, 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 blah. So they would put the vertical shift, they would write it in the front. Okay? I don't know if you can hear the bell just went off, so I apologize. Okay, so let's go over some of these. Let's see what they have for us here on the PowerPoint real quick, and then I promise I'm going to get to your homework problems. So sketch the graph of each function. Let me quickly say, first of all, shift up 2. Now, something I didn't include earlier on what I just erased, what does a negative do for us? It flips it, if you all remember. Okay, flips it down. So let's see this in action here. So the graph of y equals 2 plus cosine x is the same as the graph of y equals cosine x, but shifted up 2 units. Okay, they do a much better job drawing this than I would have. One of the reasons I wanted to use the PowerPoint. Okay, they literally just, the whole graph still just goes like from the peak to the valley, okay? It's still just 2 because it can go up 1 and it can go down 1, but the whole thing is just shifted up 2, okay? So now instead of starting at 1, it would start at, this would be the point 3 on the graph because it shifted up 2, okay? Now, the negative cosine x literally just flips, like I said earlier. Okay, so this, the blue here is the original cosine x. Cosine x starts at 1, okay? The flipped version, okay, that's the flipped in red here. The flipped version starts at -1, okay? It's kind of cool, actually. So again, just flips it. Now, what about that stretch I talked about, okay? So we have the same thing here. I really like this graph with the different colors here. The original sine function is in blue. Okay, original sine function starts at 0, 0, goes up to +1, goes down to -1, and it's going to come back to 0 at 2 pi. All right, What happens when we put a different number in front, a different stretch? Okay, makes sense with what we've learned on transformations before. This 2 sine x, instead of topping off at a 1 where the normal one does, okay, it's now topping off at 2, and it's going down to -2. It's just been stretched vertically, both up and down, okay, depending on where the humps go on the graph. Now, 1/2, it's like it's been, what did we call it? Compression. Okay, so it's a vertical compression by 1/2. So instead of going up to 1, it's going up to 1/2, and it's going down to a -1/2. Okay, so I love that graph there. It shows the difference in what we're going to learn here is called the amplitude. So anyway, okay. Oh, and here, here's the graph for amplitude. So in general, for the functions y equals a sine x and y equals a cosine x, the a here is called the amplitude. And when we measure amplitude, it's always measured with absolute value bars, always, okay? So we don't take into account for the amplitude that it is positive or negative. We're just talking about how much stretch it has. The positive or negative comes through in the graph, whether it's flipped up or down. So for instance, if you can see down here where I just boxed this in, this minus just tells us that this yellow line, I'm not sure why they wrote it in black, but whatever, this yellow line that it's pointing to flipped down instead of up. That's what the minus tells us. The amplitude, the a is still 2. The amplitude's not -2, it's just 2. It's the negative that tells us it's flipped down, okay? So find the amplitude, yada, 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 and sketch its graph. Again, quickly, amplitude, this is our A, okay? So amplitude equals absolute value of -3, so it's +3. Again, the negative just tells us it flips down. Okay, that's what the negative tells us. Nothing new. We know this. Okay, we've done this. And again, you can see they're pretty graph. The blue line is the original cosine. The red is the graph of -3 cosine x. It flipped down and then it stretched to +3, -3. Now, we take it one step further. Okay, we talked about amplitude. Now we have to talk about this elusive, what do I want to say? Elusive variable k. So this k right here is going to affect our period. I don't want you to get caught up in the weeds of this, what do I want to say, this paragraph here. What the k does is it will change our period. So it tells us essentially if I have, say I have sine of 3x, what that 3 in front of the x tells me, in front of the sine function, okay, what that tells me is that I am literally going to have 3 full iterations of sine in my regular period of 2 pi. Okay, so instead of having a graph that, you know, a regular sine graph that looks like this, I am literally going to have it 3 times. That sine graph is going to occur 3 times in the same period from 0 to 2 pi. Okay, again, if that confuses you, hang on, because we're going to have lots of examples. So here's the crux of the matter. So these functions, that's the sine and cosine, complete one period as x varies between 2 pi over k, thus have a period of 2 pi over k. So whatever your k is, that equals your new period. Okay, and again, a period is how long it takes to finish one full revolution of sine, where it goes up and then down and then back to 0. That's a period. Okay, so again, on the sine, this is a period. Where it starts and where it ends, it goes up, then down, then back to 0. That is one period. Okay, so the length of that period is going to be determined by this little formula. You're going to take 2 pi and divide it by k to tell you how long each period's going to be. Now, I don't know if you all have ever heard, but sinusoidal curves, okay, when you talk about sound waves and frequencies and that kind of thing, they're always about sinusoidal curves, and those are sine and cosine curves. Anyway, just a little food for thought. Okay, this is one that you are going to want to make note of. Again, it's in your Google Classroom, this PowerPoint. If you want to print these out, or I'll try to get them printed out on the color printer in the office before you get back. But amplitude and period, okay, what we were just talking about. So let's see how this applies. So the issue here was y equals, sorry, kind of jumped ahead, sine of 2x. Okay, what that means is our period, okay, is going to be 2 pi over 2, which means our period is pi. So instead of it taking 2 pi to go up, then down, then back to 0, it's only going to take 1 pi to go up and down and back to 0. Okay, so again, let me graph a normal sine function on top of here. So a normal sine function would be this and then this. Okay, that would be a normal sine function. Notice, again, I hope you all can see my black marks here. This would be a normal sine function from 0 to 2 pi. This red one, they did 2 complete revolutions in the same time period, 0 to 2 pi. Okay, so that's what that does. Now, 1/2, it stretches it out. Okay, so think about the period with 1/2. Think about this now. Your period is 2 pi over k. If this is your k, 2 pi divided by 1/2 is like 2 pi times 2, which would give you 4 pi. So it takes 4 pi to finish one period as opposed to 1 pi. Again, this black mark is your typical sine function. Okay, typical sine function is the black. It takes us twice that to get through one period. Okay, that's what we're talking about with k. All right, this is a good graph for comparison. It talks about, again, A is your amplitude. So on your graph, it's either going to go up to positive A or down to negative A. And then if your k is 2 pi, or if your k is 2, your period's going to be pi, because you're going to take 2 pi divided by 2. If, I'm looking at the blue one here, if your k is 1/2, okay, your period, it's 2 pi divided by 1/2, so your period is 4 pi. If your k is 1/3, okay, then your period, I'll work this one out, 2 pi divided by 1/3 equals 2 pi times 3, or 6 pi. It's going to take you 6 pi to make it through one full cycle. Okay, that's the difference in the k values. All right, quickly, I just want to say this is amplitude, this is k, which means the period equals 2 pi over 3. Okay, that's your period. Again, what does this say? This is amplitude, A equals 2. This tells me it flips down. Okay, this is my k, which tells me my period, again, 2 pi divided by 1/2 is 2 pi times 2, or 4 pi. So we can just look at an equation and figure out the amplitude, whether it's flipped down, and if they had, if I had a, +1 hanging out the back, then I would also know it would be shifted up 1. Okay, they didn't give that to us, but okay, I'm going to, again, they're pointing all of that out. They're doing a nicer job than I did. showing you the graphs. Then amplitude is not -2, it's 2. And then period, and then there's the graph. Okay, now, we've got one more thing to talk about, and that is shift. We've talked before about if a shift is in the parentheses, it's a left or right shift, like if the shift is inside the function. Okay, let me explain that a little further. Remember, if we had like f of x plus 1, this is vertical shift. If we had f of x plus 1 inside the function, it's horizontal shift. Okay, we've talked about that before. If it's inside the function, in our case, inside the parenthesis, inside the sine or cosine function, it's a left or right shift. Okay, and that just means instead of starting at 0, 0 or starting at 0, 1, it's going to be shifted left or right, and it's going to start somewhere else. Okay, now I want to point out, we know these already, but if the formula has the minus in it, so it's telling us if b is greater than 0, we shift right. If b is less than 0, we shift left. Now again, I want to point out that that's with the minus in the formula. Okay, so for instance, if I had, well, I'll tell you what, I'm just going to let them do the next one. You'll see it when you go into practice. This is another biggie. So we have amplitude, we have period, and horizontal shift. Now I will also tell you that some books, in case you ever see it, call this phase shift. Some textbooks call it phase shift. If you hear phase shift, or if you're taking a Trig standardized test, like, oh, say, Math Relays, if you see phase shift, it's the same thing, okay? Okay, let's put this sucker in practice. All right, amplitude, period, horizontal shift. Okay, just looking at this, this is my amplitude, okay? This is my K, so that means my period is 2 pi divided by 2, or just pi. So I've got amplitude, I've got period. This right here is my horizontal shift, and that is going to be right pi over 4. Okay? That's what all of that is telling me. So again, instead of starting at 0, 0, I'm going to shift to the right a little bit and start at pi over 4. You'll see they'll have a pretty picture for you. Okay? So this tells us what the domain is here. So look at the picture, okay? Again, instead of starting here, we had to move pi over 4 to the right because of the phase shift. Oh, here they called it phase shift. Because of the phase shift, we had to move pi over 4 to the right. And so the whole cycle, the whole up and down curves of sine just scooched over 1/4 of a pi. Okay? We still completed it. Now, because we also, we shifted over pi over 4, and our period was pi. Okay, so our phase shift is pi over 4, our period is 5. That's why we end at 5 pi over 4. Okay, 5 pi over 4 equals pi over 4 plus pi. Okay, that's why we ended the whole period of sine at 5 pi over 4. Okay, you have to include the phase shift into your period so that you know what your ending point is. Okay, I wanted to make sure you all saw that. And again, you know that we had the amplitude of 3 and all that jazz. So, okay, let's move on. This one. Now this one's a little tricky, as they're going to show you, because first you need to factor out the K. Okay, you're going to need to factor out the K out of this one. So notice that the 2 on the X is inside the parenthesis with the phase shift or the horizontal shift. Okay, this is how it's supposed to look. Okay, with the K on the outside of the parenthesis. So we have to factor out the K. So they do that, they pull out k, so 2 pi over 3 divided by 2 is just pi over 3. Because it's plus, okay, because this is plus, they rewrote it to be minus a negative. Okay, that was the plus. They rewrote it to be minus a negative. So all this tells me is now I'm shifting left pi over 3. Okay, so again, this is my amplitude. Amplitude is 3/4. This is my k, so my period, 2 pi divided by 2, my period is just pi. Okay, and then this phase shift, or horizontal shift, is negative pi over 3, which means it's left, right? That's what all those are telling me. I'm not sure where the missing thing is here on the period, but now, notice here, for this information, it follows that one period of this cosine curve begins at negative pi over 3, and it ends then at 2 pi over 3. How did we get that? Because of this. This was the period, okay? This was the phase shift or horizontal shift. Okay, so if you add the phase shift to the period, you're going to get where it's supposed to end. All right? So look at that graph. Again, I really like this graph. One whole period of pi, and it had to be pi because we had the 2 for the k in front there. We shifted left, horizontal shift of negative pi over 3. We shifted left pi over 3. This is now our starting point. Remember, cosine starts up. Typically, it starts at 0, 1. In this case, our amplitude is 3/4. So we start at negative pi over 3, 3/4. Okay, and then to make one full revolution, because this part took up 1/3 of a pi, in order to get a full revolution of 2 pi, this is another third of a pi, this is another third of a pi. Okay, so that's my 3/3 or 1 full pi. Again, this right here, I want to point out. This is pi plus a negative pi over 3. This is the period. This is the phase shift. Okay, that's where we land. Okay. All right. I want to start doing some questions from your homework. So let's look at some of these. I'm going to be kind of quick here probably. Graph the function f of x equals 2 plus sine x. 2 is this is vertical shift. Okay? It's not right in front of the sine, so it's just vertical shift. So instead of starting at 0, 0, we're going to start up here at 0, 2. And then this graph paper, I wish the horizontal, it was squished a little more. But then we're going to go from here to here to here. So we're going to go up 1 and then down and then back. That would be what this graph looks like. Okay, we just took the graph of the sine function and shifted it up 2. Okay, next. This is 1 minus cosine x. Now, the 1, again, that 1 is positive. The minus is behind it. So this is up 1. This minus means flip down. Now, if you remember your typical cosine function looks like, typical cosine looks like here and then back up, okay? So this one gets flipped. So we shift up 1. So instead of starting at 0, 1, we're going to be starting at 0, 2, but we shift down because we flip down. So actually, let me do it this way. Because we went up 1, this is like shifting your x-axis, if you will, up 1. So instead of starting up here, we're starting down here. Okay? Does that make sense to everybody? So we're going to go up to here, to here, to here, and then back to there. That's what the graph should look like, roughly. Okay, from 0 to 2 pi. Now, sometimes the, what do I want to say? The book will draw this window for you. Well, I'll leave it alone. Sometimes they go to the left of the y-axis. So it just kind of depends, okay? So you could also, you could keep going as much as you want. It just keeps repeating. Okay, next one, 2 sine x. That 2 is our amplitude, okay? This is our amplitude. Amplitude is 2. So instead of going from -1 to 1, it's going to go from -2 to 2. So again, sine, we don't have any shifts, so we're going to go here. Now, if this is 1 and that's 2, now this is a full cycle here. So now we're going to go up 2 and then down 2 and back. Okay, so it's just stretched. Okay, this is where the fun part starts. Okay, find the amplitude and period of the function. Again, this right here is amplitude. Absolute value of -3, which is 3. That would be your amplitude. Now, that 6 is your k. This is your k. So your period is 2 pi over 6, which is pi over 3. That's your period. Okay? That means we are going to have a very squished sine function. Okay? Find the amplitude and period of the function. We are going to finish. I wish I still had my graph here, but let me just quickly, I'm not going to graph all of these, but let's say this is pi over 3. So this is pi over 3. Holy cow. We are going to, our amplitude, first of all, there's a minus, so it's going to flip down, and it goes to 3. So let's say this is -3. Let's say this is +3. Holy cow. I'm not sure. It would look something like that. We would get through one whole period in pi over 3. Okay, essentially in our regular period of 2 pi, we'd get 6 complete cycles of the sine function. That would be one. If this is like 2 pi over 3, so we would have another in there. So we would have, that would be another. That would be another, and so on and so forth. We'd get 3 more before we got to 2 pi. Okay, I hope that's helpful. Next one, okay. What happens when your k is a fraction? Well, we had some of those, okay? Again, amplitude, I'm just going to say 2. We don't even have a negative to worry about. This, again, is your k. So your period is 2 pi divided by 1/8, which is 2 pi times 8, or 16 pi. Okay? That sucker is really stretched out horizontally. Okay? So you are only going to get through 1/8 of a cycle in 2 pi time. It's going to take you 16 pi to get through an entire cycle of cosine. Okay, that's what that's telling us. Amplitude, period, and horizontal shift. Okay, so this one, again, amplitude is 4. We don't have a k. Okay, essentially we could say k equals 1. Actually, I should have that arrow pointing from outside the, so we should say from out here, k equals 1. So our period is simply going to be 2 pi. Okay, we have not changed our period. Remember, that's the default for sine and cosine is 2 pi. And then this here is my phase shift or horizontal shift. Sorry, old habits die hard. I want to default to phase shift. Phase shift, horizontal shift, whatever, is pi over 3. Okay, that would be, if we were graphing it, that would be to the right. Okay, phase shift is pi over 3. Hope that helps. This one, okay, they have factored out the k. That's nice. So again, this is a regular sine function. We do not have an amplitude. So essentially our amplitude is 1. Okay, our k here is 1/2. So what's that tell me about the period? So the period is 2 pi divided by 1/2, which is 2 pi times 2, or 4 pi. Again, what that tells me is it is going to take me 4 pi to get through an entire cycle. Okay? Now, this is phase shift. Now, we have to be careful, or horizontal shift, whatever. Because this is a minus, I want to rewrite this as x, because that was a plus inside. I want to rewrite this as x minus a negative pi over 5. Okay? So our phase shift is actually negative pi over 5. We have to slap the negative in there because we're technically going left. Okay, so when we graph, the starting point of our graph is going to be to the left. I hope that is helpful. So this one, the trouble with this one is they don't have the k factored out, okay? So what we need to do here, I'm going to rewrite this as 1 plus cosine of 2 parentheses, okay? Then be x plus, what would that be? If I factor out a 2, okay, factoring out a 2 is going to be like pi over 4 divided by 2, which makes this pi over 8. Okay, maybe I should do that. All right, if I pull a 2 out of that pi over 4, pulling a 2 is factoring out a 2 or dividing by 2, then that makes that pi over 8. So now let's look at all the pieces. First of all, this is simply a shift up 1. That's all that is. Okay, amplitude, my amplitude is 1. Okay, we don't have a number in front of the cosine, so amplitude is 1. This is my k, so my period is 2 pi divided by 2, which is just pi. That's my period. Now, my phase shift or my horizontal shift, this right here, phase shift is going to be negative pi over 8 because on the graph you are technically going left. Again, I want to reiterate, this is like x minus a negative pi over 8. Okay, so the phase shift is actually negative pi over 8 because you are going left. Okay, you know, well, you all also know that Desmos can help you with these graphings, although I really want you guys to try to figure these out on your own without Desmos, please, okay? Because it's going to be handy going forward. Anyway, my heater just kicked on, now my board is shaking, so I'm not going to try to graph. Okay, this one, now they give us the graph, we have to figure out all the important parts. So the graph of one complete period of a sine curve is given. Now, looking at the graph, first of all, one complete period, where did we end? We ended, that is 8 pi. Okay, that is 8 pi. So first of all, amplitude. How high did we go up? We went up to 3, went down to -3. Our amplitude is 3. Our period, we can figure that out based on the graph, obviously. Takes one full cycle, it's going to take us 8 pi to get there. Now, is there a horizontal shift? Did we shift left or right? No, we did not. We started at 0, 0, so there is no horizontal shift. Now, write an equation that represents the curve in the form y equals a sine k x minus b, yada, yada, yada. Okay. So, how do we get a period of 8 pi? How do we know what our k is? Okay, well, you can kind of work backwards. So that's kind of the beauty here. So if my period is 8 pi, so I'm going to say 8 pi equals 2 pi divided by k. All right, because that's the formula. You take 2 pi divided by k, and that gives you your period. Well, our period's 8 pi, so we kind of have to work backwards. Okay, so what does this tell me? This tells me then that k equals 2 pi divided by 8 pi, which is 1/4. Okay, so if I'm writing my equation in here, this is going to be y equals, my a is 3, okay, I started going up, so I don't have to worry about a minus. I have sine, I'm obviously going to run out of room, parenthesis, my k is 1/4, and then parenthesis x, actually it'd be like -0, okay, because I hate my dead spot, because we didn't have any shift. So you could just write this as y equals 3, I'm not sure what that extra little dot is. Y equals 3, I promise I'll get this eventually. Y equals 3 sine of 1/4 x. Okay? That would be the equation, because we did not have a horizontal shift or phase shift. Okay? Now, this one. Okay, same kind of deal, but you can tell here we've had a phase shift. So first of all, amplitude. What did we go up to and down to? We went up to 1/2, down to -1/2. So amplitude is 1/2. Remember, amplitude is always positive. Period. How do I get my period? My period, by the graph, we went pi/4 to the left, which is obviously going to be my shift, to 3 pi/4 to the right. Well, pi/4 plus 3 pi/4 is pi, because it's technically 4 pi/4. Okay, so my period is 1 pi. Again, 1/4 pi plus 3/4 pi is 1 pi. Now, horizontal shift. Again, here's my shift. We went left. Okay, this is my shift. Negative pi/4 is my shift. Because we went left, you have to include the negative. Now, write an equation that represents the curve of the form, yada, yada, yada. Again, if your period is pi, you got to kind of do this in reverse. Okay, so if pi is going to equal 2 pi over k, you can easily see then that k is going to equal 2. So if I'm writing my equation, my amplitude is 1/2 times, this is a cosine curve. Okay, it did not start at 0. So cosine, parenthesis, my k is 2, parenthesis, x, now here's where it gets interesting, because it's x minus a negative pi/4. So this would actually be x plus pi/4. Again, we went left. This is like x minus a negative pi/4. Okay, because we went left. All right, so that would be the equation of your arc. Oh, one more thing I forgot. I just looked up and realized we started down. You all see this instead of up? The typical cosine function starts up like at 1. So I need a negative in front of here too. Okay, because it is flipped down. Typically our cosine function, if you remember, cosine function looks like that. So this is flipped. So we need a negative in front of it. So this would be the equation you need. Okay, I hope that helps. I know this got long, I'm sorry, but anyway, couldn't be helped. This is for section 5.3. If you need me, email me, we can set up a Google Meet.